Hi, welcome back to the Code Mentor channel. In today's episode, I'm going to show you how you can set up your local development environment for Kubernetes using Skaffold and Minikube. Let's get started. If you've tried to set up Kubernetes before, you know it's a real beast to set up. For that reason, there's an open source project that was created called Minikube. What Minikube is a one-node Kubernetes cluster with all the main functionality that you would expect in a Kubernetes cluster, but it's designed to run as a single node in either a Windows or a Mac or a Linux machine. For our purpose, because we're trying to set up a local development environment, that's what we're going to install first. Let's get started. The first thing we need to do is to install Minikube. I'm on a Mac. So first I'm going to check if virtualization is supported. I can see VMX here in the console, so it means it's supported. Now that we know that virtualization is supported, I can now install Minikube. There's two options to install it. You can use brew if you have it already set up to install Minikube, or you can just download the standalone binary, which is what I'm going to do now. Now I'm going to move the binary to user local bin. And to test the installation, I'm just going to do Minikube status, and I can see the Minikube is available. I can then proceed. Now we need to install Docker. We're almost ready to start Minikube, but when we start Minikube, we need to pass in three parameters. So the first parameter is a mapping between a folder in our file system, in our local machine, with a folder in the VM that runs Minikube. And that folder is going to be needed for some files we need to share later on. The second parameter is the memory limit. Minikube comes with 1 GB of memory limit, and that's not enough for what we're going to be running. Even though it's a bare bones application, it still needs more than the memory that is currently configured to be the limit. The third thing, it's kind of optional, but you might want to do this, is to increase the number of CPU allocated to Minikube. By default, it comes with 1. We can change it to 2 or to 4, depending on how many CPUs you have available. Now that we've installed Docker, we are ready to start Minikube. As you can see, it's downloading a VM image for Minikube. And by default, if you notice, at the top it says it's using the HyperKit driver because I specified it. So HyperKit is basically just a way for Minikube to run a VM. So Minikube is started and ready to use. Right, so before I install Skaffold, I wanted to just give you a quick introduction to Skaffold. Skaffold is an open source project, yet again started by Google, and the idea of Skaffold is to make it really easy for you to develop locally for Kubernetes. It automates any of the deployments that you normally need to do by hand for you. Also, you can synchronize files between your local computer and the Kubernetes cluster if you configure it properly, which is something I'm going to show you how to do after we install Skaffold. We are now ready to install Skaffold. So I'm just going to copy and paste this script and run it on the terminal. And it's downloading now. I can see if Skaffold is installed, and I can see it's available through the command line. Now we need to install Kustomize. Kustomize is a tool that allows you to create an entire Kubernetes application out of individual components without actually having to touch the YAML for each component. It's actually a tool that's part of kubectl, but because Skaffold requires to use Kustomize directly, we also need to download this. So let's install Kustomize. So I'm copying this script and executing in the terminal as usual. Just have to wait a little bit until it downloads and installs. I'm going to move Kustomize to the user local bin so I can call it from anywhere I need it. Let's see if it works. It's running. Now it's time to set up a project that I've created as an example on how you can leverage Skaffold to develop quickly for Kubernetes. So let's clone the project, and I've cloned the project, and you'll have here a Kubernetes app. Now we need to modify two YAML files. They are inside the overlays dev folder. So the first one is inside MySQL backups volumes.yaml. I'm only going to change the base path. So in my case I have a Mac, so I have my project inside my home folder inside project. So I also have to change the Strapi volumes to have the correct path to the project. So do you remember when I mentioned that we need to enable sharing of our home directory with Minikube? That's why, because we need to share these folders. So now we get into the exciting part. We're going to be able to start Skaffold, and if we are lucky, it will work first time. Okay, so let's do this. So I should be in the root of the project, and I just have to write Skaffold and then the environment that I need to start. In this case is dev, which is my local development environment. And as you see, it's downloading all the files from Docker, the containers that I've set up by default. We just have to wait now. Don't worry about the SQL errors, because what's happening here is that Strapi starts quicker than the MySQL database, and it gives an error initially, but then it recovers, as you can see. And we have our you can see this localhost URL. It won't work because this service is actually running inside the cluster. So we need to somehow access this service within the cluster. For that, we have this command here, Minikube service, that we're going to use. I'm going to have to open a new tab. So here I have a URL which I can use, and I'll be able to access our service. In this case, we are trying to access Strapi CMS. There is a username and password we can use, which I've put in the article itself. So you just have to copy and paste it. Where is it? It's here. So I'll use this as an email address, and this is the password. So I can access the CMS. You can see that there is a restaurant that I've created beforehand. And there's categories as well. To access the front end, we also have here a URL that we have to generate the URL for the front end. You can see that it's actually running on a separate port. It's not an amazing UI, but it does the job. It shows me the restaurants I have in the database. So an exercise we can do now is to add an extra restaurant and see if it shows up on the front end. So let's create another restaurant. So I'll go to the restaurant section and I'm going to create a restaurant in Mayfair. Amazing restaurant. Japanese is my favorite food, so I'm going to just put that here. Best sashimi in town. So I'm going to click save. Before I click save, I should pick the category. I don't have a category. It's okay. I'm going to be under French food for now. Since we are here, might as well create a new category: food. Japanese food. And I'm going to pick. But I need to correct now the category that I picked for the restaurant because I didn't mean to. It's not a French restaurant, so I may as well be accurate. So I'm going to remove it from here. Okay. So far, so good. So I've created another restaurant, and let's see if it shows up on the front end. Amazing, it shows up on the front end. So that's how we need. Okay, so we've seen very quickly how we can make changes to our front end and see the changes happen immediately. And I just wanted to give you an idea how this was possible, and I'll show you the configuration that I had to create for Skaffold. So let's go to our IDE, and here in this in the home directory of the project you'll find a skaffold.yaml file. This YAML file basically describes the different artifacts that Skaffold will automatically refresh. This section here is for the CMS, for Strapi. So here we tell Skaffold where to find the Docker file for the CMS, and also there's a sync section which we use to basically specify which folder to look for changes. Okay. The nice thing about this infer section is that Skaffold is able to look inside the Docker file, and it sees that for that infer command with the folder name, which was CMS, it will look for any copy or any command that would affect this directory, and then from there it will basically infer which files need to be synced. The sync only works one way. If I change files on my laptop, on my home folder, it will be replicated to go inside the cluster, inside the Docker container, inside the pod. But if something changes inside the pod, it doesn't get synchronized to my computer. I'll explain that a little bit more in a while. But you see, so we have the CMS folder which gets synced, and if we go back to scaffold.yaml, which I'm in the file again. So now we go back to the scaffold.yaml, and then the next section is very similar to, so for the front end, we also specify the name of the image, the Docker image, and we also specify the location of the Docker file, and we also have a sync section showing which folder we should look for changes. In a very similar way, it will look into the infer command will basically look inside the Docker file and will look for any copy that will affect this folder, and based on that it will infer what kind of synchronization we need. And it works quite nicely. An extra thing I added here, instead of just having our Node.js server start automatically, I've replaced the Node.js server with a nodemon. This is so that every time this server.js file changes, it will restart automatically. So that's something I have changed. So another set of files that is quite important are the Kustomize files.
there is a folder inside our project called base, and in base you'll find all the common settings across all the different environments for our application. So we have here the CMS deployment file for the Strapi CMS, we have the front end, we have MySQL, which is the database, and these settings are kind of the base for all the different environments. So in customization.yaml, we specify the different files that are composed that Kustomize needs to know about. So in here we are telling Kustomize, okay, for our application you need to deploy MySQL deployment.yaml, you need to deploy CMS deployment.yaml, and the front-end deployment.yaml. Also you need to create some secrets for MySQL. Note here, they are hard-coded here, but this is not something you would see in the production environment. You would be able to have, there's a random generator that you could create, or you could just create a secret in another way, which is more secure. You wouldn't, in a real production deployment, you would never want to store a password on a YAML file like this. Okay, so this is the base configuration, and then you have a folder called overlays. So for each environment, I can do some overrides. So in dev, I have my overrides, and in production, I also have some overrides, which I'm going to ignore because our focus today is the local development environment. So what the overrides did we do here? So you can see customization.yaml. Let's look at the resources section first. You have here the base folder where we are loading it. And then we have an extra file, two extra files for the development environment. So we have Strapi volumes and we have MySQL backup volumes. Remember we changed them earlier on? These are host path volumes that we wouldn't normally use in production. In production, for example, on a Google Cloud platform, we would use something like persistent disk of some kind. But here, this is a local development environment. We're just going to use the host path volume. I'll just show you again the file in case you've forgotten it. It has here a path where I specify the directory where I have stored a copy of the database I want to load into MySQL. So I have some data there, because in a local development environment, if you have a big team, you don't want everyone to manually import their database. Notice here an important difference. We are injecting, let me just go back to customization.yaml, okay, injecting extra components like this. If you want to override a component that already exists, then you have to do a patch. And this is where we have a patch here. I can show you an example of a patch that we did. And that patch was to basically, it was to set a mount path for one of the containers. This mount path actually for MySQL allows me to place a database dump file in that folder, and then when MySQL initializes, it will load it automatically, and it's quite handy actually. And that's it. I think I've shown you everything I had to show. I've shown you how to load a project, how to create a project and make changes and see them happen straight away. And now it's up to you really to give it a go, try it yourself, and maybe adapt this for your workflow. I'll be so interested in hearing feedback from you guys.
So we've reached the end of our tutorial. I hope you found it useful, and I hope you're very productive developing for Kubernetes in your local machine. If you have any feedback, questions, suggestions, please leave it in the comments section. I'll be going through all of the comments. If you like this video, please click the like button, and if you want more videos like this, subscribe, and anytime I publish you will be notified, which will be great. And I'll be very happy to get any more subscribers. And yeah, happy coding, and see you again soon.